are we live? Hopefully you guys can hear me quite well. Let me just do the average check that we usually do. And also, let me turn on the window light here so you can see me a little bit better. There you go. It should be okay now. I'm gonna keep talking for a bit just so I can hear myself in the stream. And let's have a look at this. I'm gonna keep talking for a bit just so I can hear myself in the stream. And let's have a look at this. Testing, testing, testing. Hello, hello. Testing, testing. Testing, testing, testing. Hello, hello. Testing, testing. Testing, testing, testing. Okay. Alright. Doesn't sound too bad actually. Testing, testing. I mean, the voice is a little bit low and I do apologize for that. Maybe I can turn it up a little bit. Let's see. Okay. Right, let's continue Spotify. And let me just see if I can turn the voice up for a second. Yeah, I think it's fine now, right? So you guys let me know if you can hear all of this. And also, I'm just gonna get the chat up here, just so I can see her on the other screen. And there you go. Hopefully, you can. I'm hoping that the chat's working. Let's just do one test. I'm hoping that the chat's working. Let's just chat. Do one test. Yes, chat. Do one test. Ooh, it's about to stream now. Right. OBS chat isn't working, which is not great, really. So what I'm gonna have to do is to basically just, I guess, I know it is working, it's just a little bit delayed. Okay, no, that's fine, we can work with that. So first of all, welcome. In today's stream, we're gonna be using, as you can see in the title, ChatGPT to basically summarize the Rust programming language from a C++ perspective, because I want to learn it really. It's something that's been in the back of my head for maybe a couple of months now. Rust is getting increasingly popular, especially from a systems design perspective. I think many companies are opting to use Rust instead of things like C or C++ because of the supposedly memory safety. So let's see what it's about, and let's see if we can create a very simple executable, a very simple game in this stream. And let's obviously use GPT here to help us through that. So I'm going to start it up, and I'm actually going to do a few prompts here just to summarize the language and to basically find out where we can start from and what we should be doing. Now, the plan is to use my WSL distribution on Windows here to install the Rust compilers. We're going to create a project and obviously use something like VS Code to edit that project. And we're going to be getting most of the information from ChatGPT, obviously, so like where to basically start looking for things, but also we're going to be using Google extensively to find documentation of functions or simply to find how to do things in Go. For example, I have no idea how you can include third-party libraries or anything like that in Rust. So yeah, let's get to it. So let's begin with our first prompt here. So let me see if I can just zoom it in for you to see. There you go. Let's ask ChatGPT to summarize the Rust programming language in a markdown document for someone who comes from a C++ background. Okay, let's begin with that. And hopefully it works and it's not down. There you go. Okay, so let's start reading, I guess. So Rust is a modern systems programming language designed for performance, reliability, and safety. It was developed by Mozilla Research and has gained popularity due to its unique features that make it a stronger alternative for languages like C++. If you come from a C++ background, you find that Rust has many similarities with C++, which I have actually seen some of them already, but with some important differences. Rust is designed to provide low-level control over system resources, while also preventing memory-related errors. such as null pointers, dereferences, and buffer overflows, which are a common source of bugs in C++. And this is kind of true, really. And if I'm not mistaken, Rust has this sort of guarantee ownership of objects. So whenever you create something or pass an object around, you're always going to know which bits of code own it, which is something that C and C++ don't really have. And sometimes you have to do things manually, and that's what, you know, causes a lot of bugs, really. Okay, so let's continue reading this. In contrast to C++, Rust has strong emphasis on ownership and borrowing, which enables safe concurrency without the need for complex locking mechanisms. I'm not entirely sure if this is completely correct. There's just a bit about these two things, ownership and borrowing, being able to guarantee safe concurrency, because you can still mess up in concurrency there, right? So maybe this is one of the things in ChatGPT where it's not completely true, but let's take this as with a pinch of salt, I guess. So Rust type system is also designed to prevent common mistakes such as dangling pointers and iterator invalidation. So this is true, and I know this is true because I've read things about Rust and then these features that enable this kind of thing, this kind of safety. So key features: performance. Rust is designed to be a fast and efficient language with a focus on low-level systems programming tasks, such as writing device drivers, embedded systems, and operating systems. This is interesting because by saying that it's a language for low-level systems, where you can run in embedded devices, it kind of implies that you can run in quite a few different devices, right? So that's one of the things we're going to try to put into test, or at least research some of it, because languages like C and C++, they have a sort of very, very supported ecosystem, in the sense that you can compile C++ or C code for whatever device out there that you may have. So even things like a TV remote, you know, you can run C++ and C code on that, on a microcontroller. I want to know if Rust has that level of support in other platforms as well. So let's, you know, that's one of the things that we can probably do now. So Rust compilers yeah, ARM is probably the most important one at the moment, because quite a few devices are ARM related devices, such as phones or even some like Raspberry Pis or any smaller devices like that. So I guess there is already an ARM compiler for Rust, right? Let's look at Reddit. Reddit is always always gives you the truth, I guess. Yeah, so there are quite a few ARM toolchains. Rust build. ARM compatible libraries are now part of the standard. Okay, so that is good. They can be downloaded here. Okay, cool. We've also got the actual Rust website, right, where we can get started, I guess. I like how they have an option here for the WSL, or Windows Subsystem for Linux already. Quite easy to install, and we're going to be using this in a second. We're going to get into Cargo in just a little bit. As far as I know, it's the official package manager for Rust, which is a good thing, right? C++ doesn't have that. I can see no mention here of cross compilers for Go. Okay, but it has some important information here on this website. Right. So let's see, Rust cross compilers. Let's have a look at what is available. Rust supports a great number of platforms. Okay, this is what I'm looking for. Support for different platforms. Targets are organized into 3 tiers, each with a different set of guarantees. More information and policies. See, okay, we don't really care about that. Tier 1 with host tools. Tier 1 can be thought of as guaranteed to work. Okay, that kind of worries me a little bit. So it's not guaranteed to work in the other ones, but I guess we'll see. The Rust project builds official binary releases for each tier 1 target. Okay, so those include Arch64, so ARM64 Linux. I guess like ARM v8 7 kind of thing, so that is cool. also some of the Windows builds, obviously, so 32 bits here. Darwin for macOS, so it supports macOS compilation as well. Okay, more Windows stuff, and then a general x86 64 compiler for Linux, which is also cool. Right. So there's tier 2 ones. Okay, so there's PowerPC support, there's MIP support. Okay, so there are more stuff. So let's see what the tier 2 ones. It's guaranteed to build. So I guess you can build programs in it, but not guaranteed to work as expected, which is, you know, interesting. And then there are more tiers. Tier 3 targets are tier 3 targets are those which the Rust codebase has support for. But which the Rust project does not build or test automatically. So they claim to support tier 3, but it's not really tested or built automatically in their repos, I guess, which is fine. Oh no, v7 is here, jeez, okay. Okay. PowerPC, risk, some... Okay, now this is good. This definitely has a lot more support than other languages like, I don't know, I'll take Python for example. Definitely you can't run in some of these small devices here, but also bigger projects like Java and Go, they wouldn't be supported by some of these platforms. But at the same time, you know, tier 1 is basically the tier 1 platforms are the ones you're actually guaranteed to work, so compile programs and run as you expect. If you go for tier 2, for example, it's guaranteed to build, so you can build your programs, but it's not necessarily going to work the way you expect. That's what I can understand from this text here. And then tier 3, you know, is just whatever. It's guaranteed to I guess they have some support for them, but they don't know whether it works or not completely for these devices here. And that's one of the things that it kind of loses compared to, you know, older languages like C and C++, because you can pretty much find a compiler for C or C++ for any of these platforms in here. Even less known platforms like microchip chips. So like there are microchip compilers which are way less known than any of these platforms here, and you are basically guaranteed to compile and work those devices as well. So, you know, there's a long way to go in terms of platform support here, but it's cool to know that they are at least trying, which is really good. Anyway, let's go back to Markdown here. So Rust is designed to be a fast and efficient language with a focus on low-level systems, programming tasks such as writing device drivers, embedded systems, and operating systems. Safety. Rust's type system and ownership model makes a safe language that helps prevent common errors such as no pointer, dereferences, and buffer overflows. Like, we've read this at least 3 times. Concurrency. Okay, we need to... I don't fully believe in this point here, but I guess we'll find out in the future. Cargo, that's one of the things I wanted to read about. So Rust's package manager, Cargo, I guess, is a powerful tool, that makes it easy to manage dependencies, build projects, and publish packages to create I/O. I guess create I/O, right? So I guess that's like Conan I/O or BC Packages.io. We can find whatever libraries we have in here. Okay, so it has, oh yeah, so it doesn't have any glue, but it has OpenCV support, which is a good thing. There's 100,000 crates. I guess each crate is like a recipe for a library. Which is cool. We just search for graphics, getting ahead of ourselves, but the representation of a circle, embedded graphics. Okay, there seems to be quite a few different libraries here, but I couldn't find the GL ones. Oh, there you go, open GL bindings. Okay, so we do have GL bindings here. Not that we're going to use it, but SGL is a good one as well. Okay, cool. So maybe we'll use SDL for today's project. But we're getting too ahead of ourselves, so let's continue. Rust syntax is similar to C++. I disagree. I've actually looked at some Rust code and it's very different, but with some key differences. So basically not similar. Rust has a number of modern language features such as closures, pattern matching, and algebraic data types, which makes it easier to write expressive and concise code. Cool, I do like that. It has also a more robust standard library than C++, with support for tasks such as networking and file I/O. I mean, C++ also has both of those things, but okay. Learning Rust. If you're interested in learning Rust, there are a number of resources available online. The Rust programming language book is a great place to start, and the Rust documentation is also a valuable source. Okay, I think we're ready to start, at least. So, okay, let's actually begin by installing this from the website. So let's hoping that you can see here. I'm just going to create a temporary directory for the download files here for the installation. I'm not sure if it's going to download anything, but we're here running the WSL installation of Rust compilers for Windows, I guess. So what do we need to do? Default host triple x86 unknown Linux. So let's, you know, there was a different platforms website that we checked. Let's see which tier this is on. Rust cross compilers. Let's find that page again. I'm now interested. There you go. So that is tier 1. So it's actually well supported, which is cool. So all our programs are guaranteed to build and run on WSL Windows, which is a nice thing to know at least. Proceed with installation. Yeah, let's do that. Downloading stuff. 29 megabytes plus 67. Plus 96 megabytes plus 20. 117 plus 30. Okay, so it's fairly chunky from the looks of it, compared to, like, you know, GCC or maybe not Microsoft compilers because they're quite big as well, but yeah. Okay, so as you guys say, you need to start your current shell. This guy go up. Nope. This would reload your path environment variables. Did it install anything? So let's have a look. And also let me keep the view count here so I can peek how many views there are every now and then. Okay, so going back to here. Go up. Nope. So it didn't really install properly. This will reload your path environment variable. Ah, okay. It's because I haven't run the thing, have I? So let's. Home is not defined, is it? Oh, it is. Interesting. Anyway, so what I can do is source, and then I can do cargo and cool. So that is something that I guess I have to add to my Vimasi, right? So let's do that. ZSHL, sorry. Start with Visual Studio Code here. So we're going to source. Was it cargo env, right? Yeah, that's the one. Cool. So if I source z.c, we should have everything every time now. Okay, cool. Now, how do I know if the compilers are working? So rust up. Okay, rust up is also available. Cool. The rust toolchain installer. Okay, so this is like an update kind of program that I installed. Yeah, Rust up installs the Rust programming language from the official release channels, enabling, okay, you to easily switch between stable, beta, and nightly compilers and keep them updated. It makes cross-compiling simpler with binary builds on the standard library for common platforms. Okay. Let's see what the active ones are. Rust up, show. So I have obviously the compilers for my machine, I guess, the x86 64 unknown Linux new compiled version. So Rust C. Rust C is the actual compiler, right? I'm taking. Please tell me there's a man page for it. No, there is not. Okay, cool. Now let's ask ChatGPT how to start a Rust project for a beginner with cargo packages and good directory structure. Let's see. Here's a step-by-step guide to creating a new Rust project. Start Rust and go. Yeah, we got that. Rust and cargo. Oh, cargo. Use cargo to actually start a new project. Is that correct? Let's actually double check that. Cargo build to build a project with cargo build, cargo run, cargo test. Alright, so cargo is the main tool that you sort of interact with, right, to compile and run your Go code. You don't actually use Rust C from the looks of it. I guess this thing internally calls it. So generate a new project. Yeah, so okay, so this is actually quite cool. Create a new project, open a terminal, navigate to the directory where you want to create a project, then run the following. Okay. So let's do that. Let's create. Let's make a new directory here called Rusty Pong or something. Was it cargo new Rusty Pong or something? Okay. Okay, right. It didn't really do what I wanted. Create a directory of that. We can just move it out. And then we can delete that one, I guess. Okay, now we are here. Let's open it with code. It still opens at a ZHLRC because I didn't pass the thing in the path. I'm going to put my microphone directly in front of my mouth so you can hear it. Okay, so we've done the first step. Configure dependencies. So, oh, cargo uses TOML. And TOML is basically just a minimal configuration file, which is kind of nice. I kind of like it, really. So, if I'm not mistaken, Conan kind of uses something very similar for the configuration files, right? For the txt, or maybe not. Maybe I'm talking absolute trash here. But yeah, it's a very simple configuration file, which is cool. So let's set our dependencies, and then we got cargo.io, right? Nope. Crates.io, that's the one. And let's set up SDL here. So there's no readme, cargo add. Okay, so that's how you add it. Okay, so it's all you gotta do is just run it, I guess. Cargo add, and then it just downloads all the pre-built stuff for you, or the source code at the very least. It's quite big from what I can see here. I'm not sure if the C++ version of this package is as big as this, but you know. I'm gonna do something legal. I'm gonna stop this and actually follow the second suggestion, which is kind of what ChatGPT told us to do. So I can, okay, dependencies, cargo.toml. Okay, so we have cargo.toml already in here. Dependencies, and then we've got that. I mean, it explains to us how we added the dependency here, but not how to actually pull it. So far, we've only got the dependency here in the cargo.toml. It's cargo update, I guess. Maybe not. I'm not sure if it's actually downloading the SDL dependency that I've added, or if it's just doing something entirely different. I don't really know, but oh well. Let's assume that it's actually downloading the SDL dependencies. So there's a library for serializing and deserializing data. Cool. So adding source code, main.rs. rs, I guess, is the file extension for Rust. So let's do that. And that will be inside the source directory, right? Okay, cool. It thinks it's JavaScript, but it's not. And cargo build will do everything for us. So let's try that. Cargo build. Okay, so now it seems to be running, compiling everything, I guess. And what does it compile to? Compiles to target, I guess, and then debug. Yeah. Rusty Pong. Hello world. Okay, cool. We've got our first project compiling in Rust. I keep saying Go, but I really mean Rust. And cargo run will obviously run the project. Okay, cool. So you can run it from here. Cool. Sounds good. Adding tests. Create a test directory. Okay, we don't have that, so let's do that. Let me zoom in here so you guys can see it too. Test direct. Is it tests or test? Okay, cool. A new file, and then we're gonna call it my tests or something. .rust, and then we can add this to our test here. Cert equals 2 + 2 = 4. Yeah. To run your test, you just gotta type cargo test, right? I mean, so far so good. It's a fairly easy to use CLI, right? You just do everything through cargo, and it sets up. I mean, you expect to have certain project structures set up, because I'm guessing that if I take my source code out of SRC, it's not going to work, for example, right? That's one of the tests we can do actually. So move SRC to SRC2 or something. And let's do that. Cargo build. And let's also remove the target. Let's remove that with RF here. So if I do cargo build, is it still going to work? Cargo build and then cargo run. There you go, it doesn't. Right, so it does expect you to have those tree structures exactly in the same way as, you know, as they say on the website, which is fine. At least you enforce people to do the same thing all over, which is not a bad thing. There you go. And now obviously if I do cargo build and then cargo, I mean, compilation for this size project seems to be quite slow just for a Hello World program, but I'm not going to complain about that now. Okay, now we're back to working. And then if we can do cargo test as well, compiles and then runs the tests as well. Okay, cool. So good, so far so good. Don't hate anything here. I do actually like the way they enforce you to have the same directory structure for your source code and your tests, which is good. So organize your code. As your project grows, it's a good idea to organize your code into modules. Let's create a lib.rs in the source directory. Okay, so you can create modules, which is good, right? Modules is usually a collection of packages or functions or something like that. You can use the my module in your main RS by, okay. So I can have a different file here, basically that's what it's saying. And we will call this sort of lib.rs, right? And let's paste that into it. I'm not really looking at the syntax right now, but it doesn't look too bad. I mean, you've got module, mod, my module, which kind of reminds you of the C++ namespace, which is cool. And then inside the module, I guess you define the function, right? And inside here, you do mod my module, I guess. And VS Code actually is doing a very good job of already finding a module, which is not bad. Okay, and that just imports the module in. So I can now do, what is it? My module to dot. Is dot the syntax? Is this the syntax? No. What is the syntax to? Does it just import my function here? No, there's no way, right? You don't have to put my module in there, in the front of it. So ChatGPT is lacking in that sense, if it doesn't work. Well, let's see. Okay, so we do get a few errors. So this is one of the things ChatGPT is lacking on. My function is never used, even though it is. So it's probably because I'm not calling that function correctly with the namespace of the module or something like that, I guess, right? So including modules in Rust. Rust by example. Okay, so it does have the namespace, seems here. So really, I have to do my module. I guess they kind of did the same as C++ here, which is cool. I like that. It still doesn't work. Expected this, found the keyword. Right, let's crack on then. My function is never used. Why is it never used? Let's again look at what they're saying in the actual Rust website. There's some generics. Cool. I mean, I don't really want to read all of this, so how to include, how to create and include modules with functions in Rust to other files. Let's see if it does a better job now of giving me some actual working code. Place the module with the RS, okay. Oh, it loves this my module and my function example, doesn't it? So you have to say pub to declare that this is a public, I guess, an exported function of this module, right? Huh. Let's see if that's what it missed on. Not quite. Did I also forget the Okay, we're kind of getting there, I guess. Let's see now. The pub keyword makes the function public, which means it can be used outside of the module. To use the my function in another file, you need to include the my module. You can do this with, okay, so basically I also forgot this because it needs that there. See, this is where I'm thinking C++, and I'm thinking of include directives where it doesn't have the semicolon, but it's still not working. And let's actually clear this and look at the first error and see if there's anything useful. One in my function is never used, but it is. See, now this is just giving me the function outside the module. Okay, this is creating submodules, which is fine. Okay, now let's actually read the errors and try to make sense out of this, because clearly ChatGPT is not helping us here. So the first thing is a warning: my function is never used, even though we are including it right here on the main file. And a warning again, file not found for module, my module. So this is the, I guess, the main thing, right? Ah, okay. See, ChatGPT told us to add this as a lib.rs, but it seems like it has to be my module.rs, right? So now, there's a build better, it seems to have less errors. So cannot find function, my function in module, my module. What if we remove the module name? Does it still work? Still doesn't. Just bear with me, because we'll get there eventually. Cannot find function, my function in module, my module. Function create my module function exists, but it's inaccessible. Create my module function exists. Function, okay, why is this not accessible? More information is there. Okay, let's have a look at that and see what this will explain to us. And then resolve name was not used. Yeah, obviously something that does exist. Please verify that the name wasn't misspelled and ensure that the identifier being referred to is valid for the given situation. Public static. Okay. If the item is not defined in the current module, it must be imported using a use statement, like so. So this kind of sounds very similar to using. What if we did this, like use my module, my function? Does that make sense? No, it doesn't. Expected one of that as it's still not accessible, right? So this is where we come up to Google, because ChatGPT failed us in this case. So Rust including modules compile. You don't need the mod hello in your hello file. Code in any file but the crate root for executables is automatically namespaced. Okay, so we don't need that. So that's what our first that's what the first prompt in ChatGPT told us to do. Okay. So basically, Stack Overflow 1, ChatGPT 0 in this particular case here. So apparently it's just like Python. So whenever you include a function, or you write a function in a file, that gets namespaced automatically. It's good to know. So why is the mod keyword available? That's an interesting question. I mean, when you're creating a module. Well. Okay. Cool, now we've learned how to include modules in a very simple way, I guess. Let's start with the bread and butter of this stream though. So, write a simple I guess GUI program, Rust program using SDL2 cargo package that shows a window. Right, let's see if it's able to do that successfully, or at least get us to a fairly comfortable place where we can just just go from there. And while this is generating, I'm actually going to look at how to include external crates, because I think that's, maybe it will not work. Rust extern crate versus use. What does that mean? I think use is used to import identifiers into current scope, and extern is used to declare an external module. But this understanding may be wrong. So extern create foo indicates that you want to link against an external library and brings the top level crate name into scope, equivalent to use foo. As of Rust 2018, in most cases you won't need external crate anymore because cargo informs the compiler about what crates are present. Okay, so let's assume we don't need that anymore. So what we can put here is use SDL2, I guess, right? and then we're going to use all of these other things as well. How do the comments? Okay, so third 5 packages here, and types. It's not what I wanted, thank you. Do we need SDL12 system? I don't know. Let's actually look what's inside our cargo.toml. SDL12. Oh, I did say SDL2, right? Which one is it? Let's do SDL2. 0.35. 0.2. Okay. Where are we? So this is SDL 1.2. I don't want that. So let's see. Please use SDL2 as the cargo package, not SDL12. I mean, whether or not this code will still work, that's debatable. But we will see. How does this differ from this example? Event window color. Event window. There's no color, but at least it's still generating, right? And again, I'm going to try and copy and paste this, but I do think it's probably not going to work, right? There's too many things that could go wrong in this particular example, so it does explain the code as well, but I'm not really interested in that at the moment. Does it compile? That's the question. And again, it's using SDL. Oh yeah, SDL2. That's fine. Oh no, what am I talking about? I asked it to generate a code of SDL2, but it was SDL2 before as well. Oh, interesting. Anyway, doesn't matter now. Well, let's see, does it build? I'll be extremely surprised if it does actually build. There you go, it doesn't. Ooh. I see one of the things they haven't improved in Rust are the error messages. Right, this is quite ridiculous. Linking with CC failed. So it is actually using, it's actually linking the C++ library here. Unused import video window. Let's remove those at least. Unused window, unused import render canvas. Let's do that as well. And SDL is not used, and my function is never used as well. Let's remove that. I mean, not that it's going to help, but let's recompile. Okay, so now we just get a CC error, which is fine. I don't really want to understand this code yet. Let's try and compile this one here. And if it doesn't work, we'll resort to actually looking at like Stack Overflow or something. And as far as I can tell, this is just use SDL2, right? Let's see if this compiles. No, it doesn't compile as well. And there is an unused import there. Maybe it's because I don't have the system packages, right? Let's actually look at this. So symbols, What are we grabbing for? We're grabbing for SDL. That grab did not work, but I have a strong suspicion it's because I don't have the system packages that I previously told me to add here. So let's try that. And I also don't have SDL installed on my system, which is a different issue. So let's select a version for SDL sys. Okay, let's try a version that actually works, I guess. Huh. So that didn't work either. So fail to select the version for SDL2 sys. Required by package SDL2 version, which satisfies dependency SDL2 equals this. The package SDL2 sys links to the native library SDL2, but if it conflicts with the previous package which links to SDL2 as well, which satisfies dependency SDL2 sys, package rusty pong. Okay, only one package in the dependency graph may specify the same links value. This helps ensure that only one copy of a native library is linked to the final library. Okay, try to adjust your dependencies so that only one package uses the links SDL2 sys value. For more information, let's select version, which could resolve this issue. What if I just remove that? No, it doesn't work. Okay, it still didn't work now, even though I put the same version. So SDL2 is really cannot find real SDL. Okay, that's easy though. We can just install them. So sudo apt get install SDL2, right, or something like that. There's SDL2 dev or something. It is not. Let's see that. Ubuntu install SDL2. Oh, libsdl2 dev. Amazing. It's 10 megabytes, not too much. Okay, when is it going to finish already? I really need to crack my neck, but I just can't do it. Okay, so now let's see if it compiles finally, shall we? Cargo build. Yay, it did compile, so like, does it run? That is the question, so cargo run. I kinda think it's not going to, but maybe ChatGPT will really impress me, which it did, so that's cool. It does have a window here. And okay. Well, now let's actually take a look at the code so we can we can kind of understand some of it. So the use statements kind of serves as sometimes like an import, I guess, but also if you use a particular function or a namespaced type, such as like I guess an enum or a struct here, it seems to bring it into the scope, so you can then use it as a normal like local scoped variable. So that is interesting. You seem to be able to create variables with a let statement. So let kind of similar to, is it TypeScript that has this? I don't know. Okay, so video subsystem. I don't understand SDL too much, but I know there's plenty of documentation online. I'm more interested in the way that you do things in Rust, not like how SDL is working in this case. Okay, so video subsystem. It seems to return kind of like a const object here, and then from that it does a position centered, which itself I guess returns a window object, and then build returns a window object, I guess, and unwrap, which is interesting. But I do like the syntax though, it's very clean. So my window, let's change that to my simple pong or something. 800 by 600 is fine. Now let mute. What is mute? Let's take a look at that. Let's ask ChatGPT. So, Tommy, why are you learning Rust? Well, Tommy, I just want to learn it really because it seems to be a fairly kind of popular. I'd say now it's not as popular as C++, obviously, because there's a lot more C++ code out there, but it seems to be up and coming as a language, and I thought, why not? I mean, ChatGPT is here, and I can probably spend a few hours just learning the basics of the language, so I can see how it works and create something simple out of it, like a pong game or something. So yeah, that's why I'm learning really, and I thought I'll do that on the stream just to to record myself doing it. So, and yeah, thank you for watching, by the way. So let's learn about the difference between mute and not mute, I guess. In the Rust programming language, what does mute mean? Do you know Rust, Tommy, or are you just a C++ person like myself? What do you tend to do? So in Rust, the mute keyword is used to make a binding, a variable mutable. Okay. So it's the opposite of const, I guess. So when you declare a variable using let keyword without mute, the variable is immutable by default, and its value cannot be changed after its assignment. That's very smart. That's very smart. So just C++, I don't think learning Rust would get me any further. Yeah, I mean, I kind of feel the same, to be honest, but you know, from looking at sort of jobs that are available out there, it's quite clear that there's quite a lot of Rust jobs compared to a year ago or so, and I can also tell that a lot of companies are choosing to port C and C++ code to Rust. So I thought, you know, maybe it's useful, not for the moment now, but maybe in like 5 years time or something, you know, just having that experience at least. But yeah, C++ is my language of choice all the time, and I pretty much love it, so like I don't think I'll ever stop doing it. It will always be my main language. But yeah, what's interesting here though is that whenever you define a variable in Rust, it's automatically const, and you have to declare it as mutable for you to be able to change it, which is, I'm not sure if I like it. I mean, every variable is const by default. I mean, it's interesting. I mean, something that's definitely different from C++, I guess. You cannot assign again after you. Okay, cool. So all these variables here, you can't change the values of them, or call functions that will change their internal state, I guess. So, except canvas. Okay. I have no idea what this means, but okay. So obviously these are just function calls, fairly standard. Let mute, event pump, unwrap. So when you get a quit event, it breaks out of running, which is kind of like a go-to. Well, what I do is my own projects alone and sell them online, so I don't think I'll work alone. The same, yeah. Yeah, I mean, sounds like you got a good relationship with programming there. You do your own thing. I wish I could do that. I mean, currently I'm just working for a company doing C++, but I wish I had my own portfolio and could sell my stuff, you know, online on websites like Freelancer or Upwork. Maybe I'll do that in the future. It would just require a lot of time for me now, starting that from scratch, because I don't really have a portfolio. But yeah, I mean, let me know what you sell. I'll take a look at it. Hopefully it's, you know, quite interesting to me. If it's like programming related, I'm happy to maybe support you. So, where are you talking from? Are you in the UK, America? I'm probably guessing you're from America, right? It's quite late here in the UK and not many people are awake at the moment. It's okay, let's explain how to write loops in Rust. I sell cheats for games. Okay, cool. That's definitely interesting though. Is it like you sell the cheat codes themselves, or you sell like programs that will sort of like crack the games, or you know, that kind of stuff? Not judging, by the way. It's definitely cool. I've definitely used you know, cheat codes before in programs that will cheat games as well. So the while statement loops, condition is true. So while some condition, the for statement is used to iterate over a collection of items. Okay, so there is range 4 or element 4 and while loops in the same way as C++ in this case. You can also use a range loop to specify a number of times. Cool. Okay, this doesn't explain this here though. So what syntax is this? I sell just the compiled cheat code itself with the DLL format. Some people who buy can inject elements. That's interesting. So you deal a lot with sort of, you know, I guess reverse engineering the game's APIs and creating DLLs that's gonna sort of inject some mods or something like that, right? Which is definitely cool. DLL injector, so it works kind of like this. Okay, cool. Yeah, that's definitely interesting work, dude. Have you got a GitHub or something? You got any like public projects? I'm happy to plug it in here as a comment so people can see in the future. Maybe you get like like 10 people watching this or something in the future. Not many people watch the streams live, but over the weeks they tend to show up. Anyway, let's have a look at what kind of fucking syntax this is. Yeah, I can imagine, like, you know, there are many gamers out there, and some of them are willing to pay, you know, good money to get the mods and their cheats in, so I'm kind of having not midlife crisis, but something like, you know, just trying to think of what I want to do in the future. I definitely don't want to work for companies my entire life. I want to do something like, you know, for myself. So the Rust code snippet is a loop process to event an event pump, which is a queue of inputs such as keyboard and mouse events. The loop uses a break statement. Here's a breakdown of the code syntax. It still doesn't fucking explain what this is. I also need to stop swearing for YouTube purposes, I guess. That's the reason why I started to learn code, because I wanted to create something my own way. And now here I am, creating cheats, but also working on some secret stuff. That's cool, yeah, that's definitely cool. I mean, as long as you're happy with what you're doing, which sounds like you are, you definitely got it sorted, dude. I mean, having the internet nowadays is amazing, isn't it? You can just meet people who will sometimes work on the same projects as you, but you can also learn a lot from other people. And also like a lot of documentation, so anyone can get into this kind of stuff. Like coding, that is. What did you do before coding, if you don't mind me asking? Like, it's for myself, I've always been kind of coding really, like since I can remember. And then when I was old enough to get a job, I started working in it. So, but I worked a long time for free for like people doing their backends online and helping their websites out and stuff, and never really got paid anything for it. But it was quite an experience, and I enjoy doing that kind of stuff. I'm sure that everyone goes through something similar, right, when beginning to code. Yeah, no, that's nothing really. I just started coding a 10. Never got a job in my life. Okay, yeah, that's cool. I mean, and if you're doing it well, like, you'll never really have to get a job in your life. That's the dream, right? I'm still struggling to understand this bullshit syntax. What is this? Is it just like a go-to kind of thing? This creates a loop body with the label running. This is a for. Okay. Loop labels Rust, right? Lately I'm really into AI as well. It's very interesting. Yeah, I work in AI. I work with people at Microsoft that do AI, so I'm not a researcher myself, but I can kind of, well, my job is to really implement the neural nets and stuff into a sort of Windows system program or a driver, so it's definitely interesting. I mean, you should, if you're really interested in it, like, just go to Hugging Face, get some working models, play out, and see if you can make anything out of them. Like, that's what most people are doing nowadays. And this website gives you sort of free models for image analysis, language models like GPT. Obviously not ChatGPT, like GPT-2 you can get here, I think. And you can just, understand how those things work, and it's quite nice actually. Well, yeah. If you want the link, by the way, I'll post it here. So that's actually, I mean, in case you didn't know before, but yeah, this is, I posted on the comments there. Hopefully it's sending. I'll post it through OBS. Let's see, it may take 10 seconds or so. If it doesn't send, let me know. Oh, there you go, it did. But yeah, it's mostly, if you're a C++ guy, you should probably learn some Python for AI as well. Like, most of the AI stuff is in Python nowadays, which is ironic really, because the under the hood libraries and the allows that you can use for AI in Python are written in things like C and C++. But if you just want to try out those models, like, Python is usually the way. And yeah, it does teach you everything in there, by the way. As soon as you click on the model, it'll show you how you can load them. Right. We haven't found the label. Yeah, Python for me is also, man, I do it a lot because of work, and it's actually one of the first languages I started learning, but it's more like a glue language for me. It's not really for production stuff, but if I just want to do something quickly, I tend to use Python. Loop labels in Rust. Let's have a look. Nesting labels. This is the syntax. It's possible to break or continue outer loops when dealing with nested loops. In these cases, the loops must be annotated with label, and the label must be passed to the break continue statement. And the break must be passed to the break continue statement. Okay, so you break out of outer loop. So when you say break, you gotta provide which loop you want to break out of, Cool, cool. So what is this code doing? Enter the outer loop, inner loop, enter the inner loop. This would break only the inner loop break. Also, if you do break without anything, it breaks the immediate loop. Okay. And if you provide outer, it breaks the outer loop. This point will never be reached. Okay, cool. Rust looks like a harder version of Python. I kind of agree with that. There are certain things that they definitely stole from C++, like the way you do not modules but namespaces here. It's like exactly the same. This is very similar to not C++ but like Golang, it seems. And then there's some like let statements there, which is like, I guess, TypeScript, right? So they seem to have stolen like the best things out of the best languages. So I mean, this label stuff kind of reminds you of a go-to label in C++, but obviously works entirely in an entirely different way. It's not as unsafe, it seems, and you have to provide where you want to break from into your break and continue statements, which is interesting. I mean, it helps you, in this case, it helps you read the code a little bit better, in my opinion. Compared to the C++ alternative, which is just the break without anything. You've got to figure out where you're breaking to and where you're breaking from, if it makes sense. But yeah, at least Go has that. That's cool. At least we can understand this code here. I always use VS Code or something. Sometimes using ID like Visual Studio. At work, I use Visual Studio quite a lot, because if you're developing Windows drivers and stuff, then it's my understanding that there are certain tool chains that are only available in Visual Studio or work very well with Visual Studio, and it's very difficult to sell Visual Studio Go. When I'm doing smaller projects like this one here, or just any smaller C++ project, I tend to use VS Code because it's a lot quicker than Visual Studio. I've worked with Linux a lot before as well, so I used to use like CLion. I'm not sure if you've heard of it. It's another C++ IDE by IntelliJ, and it's really good, if you want to give it a try one day. But I just tend to stick with the lightweight stuff like VS Code, or if I'm on my Raspberry Pi coding, you can see videos of that in the channel here. I solely use like Vim, for example, just NeoVim, because it's just even lighter than VS Code, like much better when you're restricted on memory. So okay, so this loop will call the event pump, right, which is mutable here as well. It looks at each event, and this is a match. Okay, so match is kind of like a switch case, I guess. So if a match is, okay, so this is pattern matching. I like it. If his event quit, whatever, then you break into running. Anything else will do nothing. Cool. See, this is quite convoluted. This is, I guess I like the pattern matching here, but like they could also have done it with just, you don't have to provide anything here, I guess. Does this still work if you don't provide anything? Let's try that, shall we? Okay, so it does require you to to not do that. Yeah, that syntax is weird, isn't it? Like the compiler knows that if you don't have anything here, you're just not doing anything with the other types. But for some reason they require you to add this weird fucking bullshit here. Well, that's okay, man. I'm not gonna complain. So cargo build and cargo run. Okay, so I still have my simple window here. Cool. Well, let's paint it to black, because this is how Pong is, right? So it should be black there. Okay. Now let's get ChatGPT to actually create us a two, I guess, rectangles on the screen, 2 white rectangles. Okay. Write Rust code that uses SDL2. I'm gonna create 2 rectangles, 2 white rectangles, and a black window. Do you have any other tips? Where could I learn AI other than Hugging Face? I'm not really an AI person myself. Like I know very little of it. Sorry, drinking my coffee there. But I did a lot of computer vision work, like OpenCV and that kind of stuff, and I mainly learned from just online courses, really, and like a very few books, really. Like if you want to, as I said, like if you want to get into AI, Python is your way to go, because most of the resources will be in Python. But there is no Riley book here on machine learning, I think. Hands-on machine learning is called, and that's the one I have, and it's really good. It explains, you know, the basics of machine learning with scikit and TensorFlow, which are two. They used to be more popular than now, but 2 very popular Python libraries. So it at least teaches you some of the theory, and you know it's quite mathsy, if I'm honest. Like if you're not into maths, then I mean this book can work for you as well, but you are going to come across with a lot of maths. You don't necessarily need to know the maths. It just shows you the theory, but it gives you plenty of working examples that you can just copy and paste and try things out here. So this is a really good book if you really want to get into it. But as I said, it's going to be Python, unfortunately, and most of the books that I've seen that are really, really good for teaching machine learning will be Python. It's just the framework that every researcher uses. So, okay, so now we've got set your color. So apparently we can do color back here. Does it compile? It does still compile, nice. Now we need to create the 2 rectangles, right? So I guess we can do that inside our loop here, right? So maybe not inside the loop. Yeah, where's the game loop? What the hell? Usually there's like a while loop somewhere. But event and event matching. Is the loop keyword an actual loop? Okay. Loop is used to define the simplest kind of loop supported in Rust. It runs the code inside the loop until the... Okay. So this is the game loop. That means we can do this here, I guess. And then we can draw the rectangles in there, right? So we'll draw the rectangles and then present them. Okay, I'm gonna try these. Thanks for all now. My projects. Yeah, see you. And if you want to, you know, chat in the future, make sure to subscribe. And yeah, it was nice talking to you, man. Good luck in your project. I'll see you in a bit. I need to learn what these unwrapped things are. Oh yeah, if you're still here as well, if you want to join the Discord, I'm usually online in there, chats and stuff. If you want to get help in the future, tell me. I'm not sure if you're still here, but yeah. am I doing? No, I'm going back here. Let's try that again. Okay, can't go wrong. So rect new user of undeclared. Okay, that's because we have to, I guess, use that. So it will be rect. Okay. What does the braces mean? Optional curly braces. Okay, I don't know what the curly braces are for, but let's just compile that for now. And it didn't work, right? Why did it not work? So the size is width and height, I guess, and then top and bottom. Canvas.present. Where's canvas dot? Canvas fill rect. Let's have a look at this docs.go. Canvas, okay. Canvas is a window, which is where can I get a window? Is it just me or this is really badly documented? There you go. Struct window. What is it? Fill rectangle or something? Into canvas. Gives you a canvas builder. Okay. Tab that allows you to build window-based renderers. Okay. Build. Will give you results of the Windows canvas and the integer or STL error. Okay, so okay, that's cool. It's like Golang. So it gives you a result or an error. I guess will be, if there's an error, will be invalid, right? Okay, cool. Window canvas. What is the unwrap? I guess it takes care of the error, right? Know that it's possible to manually customize panic with expectable unwrap, otherwise leaves us with a less meaningful output than explicit handling. Okay, so unwrap just checks if it's a none, and if it does, it's gonna panic. Okay. far as we know, this is a canvas window, and that then has a type of, let's zoom in here so you guys can see as well. And then with the canvas window, we do, for example, fill rect, right? There you go. There's a rectangle on the current rendering target with the drawing color. Passing none, we fill the entire rendering target. Errors if drawing fails for any reason, like a driver failure. Okay. Present. Okay, let's have a look at what present is. Replace the screen with any rendering performed since the previous call. SDL's rendering function to operate on back buffer, that is. Calling a rendering function such as draw line does not directly put a line on the screen, but rather updates the back buffer. As such, you compose your entire scene and present the decomposed back buffer on the screen as a complete picture. Yeah, so that should have been inside the loop, right? I guess. So I draw a color. Wait, what? What did we have here before? So okay, let's try and compile that. Cargo build. Oh. Cargo run. It still doesn't show my pong here. My two squares. And why does it not show that? That's a good question. Why is it not showing now? Let's have a look. Does anyone come across SDL2 Rust draw rectangle? Let's see. So how does this person do it? Clear, and then we draw the rectangle there with what? Rect new dot unwrap present. Okay. Yeah, where do I put the collar? Ah, okay. Of course, is the jaw collar in there. For example, if I do it now here, like white, I bet it will work now. There you go. I'm such an idiot. Okay. Now let's create a function that will actually draw a rectangle, right? Draw a paddle. How do I pass in the object? As far as I know, it needs to be a. Here's where we have the type, right? SDL render canvas. Does this work? Let's have a look. What are the built-in types in Rust? Let's have a look. I'm looking for the integer types. Okay, i8. So really we want the i32, right? Or the i64. It's safe to assume the number is positive. It showing no signs. Uses to use complement, cool. I32 and Y, let's put it as I32 as well. Now we're just going to copy and paste this code here, just one of them. Oops. I need to know the documentation of rect because so it's x and y, width and height. Okay. X and y, width and height. So it'll be x and y here. Width and height. Let's say the width is like, for intents and purposes, like 25, and then the height is like 75 or something. And the canvas. Can we get the set draw color or something? Yeah, we just have to call set draw color, right? Of course, we have to do this as well here. And that is it, right? As far as I know. So we finished that. Actually, drop paddle, and then we've got the canvas. Let's say we do on 100, 100, and then that is it. And then we do another one as well on 200. 100, and we can get rid of this, right? I'm sure it's not going to compile, but we'll see why. Construct. Okay, so let's see. Let's use ChatGPT in this case to create a function that a Rust function that takes a generic struct type by reference. Okay, so you gotta just put a T in there. That's okay, I guess. So draw paddle of T, canvas of, I guess, T there, right? Is that the type there? Yeah, render target. It's probably not good code, right? But let's see if it compiles now at least. Okay. Unused import render canvas. Okay. Okay, maybe if I do this. It has to be SDL2. So render type. It has to be a trait, right? So kind of like a range in C++ or something that says what kind of interface this is. I'm guessing. I'm not going to go too much into detail, but this is what I'm guessing here. Render target, right? Is it going to work now? Mismatch types. Expected canvas. I'll consider borrowing here. Note and function defined here. Let's use ChatGPT to save our souls here. You gotta declare that it's mutable as well. Okay, so I'm gonna borrow it here. Run the canvas of window. Okay, so this is kind of what I want to do, right? Let's see this. Is this gonna work? This might be mismatch types. Not expecting expected mutable. A reference to SDL combo found struct canvas SDL video window. Okay, is it because of the way I'm calling it? Okay, so you got to pass in as immutable as well, so it forces you to do that. Kind of like it, I guess. Let's see if that compiles now, right? Okay, it does run. So what if it is now, for example, event key? Is key a thing? Let's read the documentation and see. I just want to get the paddles moving, that's all, and then we can call it a day today. Alright. Got the event handling here. Key presses. Come on, give me the key presses key down. There you go. Maybe key pressed. Okay. There is a key code. Let's see this. So key down. Anything, and then break out of running after doing this. Except we're not. We're simply gonna, I guess, do a remute. You know, my paddle position or something. Let's start with paddle Y or something. That'll be 100. Does this work? Plus one there. So match struct first. It would be cool if you can match like a particular struct that has like the key code of X or something, you know. Match X, okay. Struct value Rust. Okay, this is what I want. This is exactly what I want. It's an option key code. What the hell is an option? Non-sumty. Okay. Let's hope that it matches anyway. So, what is it? Key code? is this. We're gonna do that. Is this gonna compile? What do you guys think? Let's have a look. No, it doesn't. Expected option. Okay, so option I guess is like an optional, right? Enum core option. Let's see if it's gonna run now. There's assigned to but never used. Okay, so that is a good warning because now X and Y, right? So we could have done it here. Okay, cool. We got paddle moving. And obviously if we did the same thing the other way around, key down and then it's plus or something, we leave that as it is, and then we obviously put that as minus. Let's do 2 as well, just to speed up things for now. Obviously this is not dependent of the FPS, as you can probably tell. Yeah, it seems to work fine. Right? Obviously we need to, you know, when you press the key down before it repeats, what we've got to do is actually set the state of the paddle to moving up. And same thing with down until you turn the key up again, and that's how you get the continuous motion there. And obviously account for the FPS changes here, so you know it's running quite fast actually, but on a slower machine it's not going to move as fast. But I think, you know, that's a lot of learning today, and it's actually quite interesting to learn Rust. And yeah, I'm hoping that you guys enjoy this video, and I'm going to be doing a lot of, hopefully a lot more Rusty videos, because I want to learn Rust and I want to actually learn how to write good code in it, just so I can say on my CV that I've got Rust experience. But, yeah, thank you for watching, and I hope to see you next time, and bye bye.